Hi Precalc. I've got a lot of questions in my feed. When I get so much in my inbox, I just have to start with the earliest ones because I'm just, it's just too full. So let me start here. I'm at 4.6. I'm number 27, page 315. Okay, so on the left side here is the standard table for the cotangent. And I'm going to use this table. I'm going to convert this table using the new function they gave me. So there's a 3 that's multiplying the cotangent function. Anything that's outside of the function affects the range. So this means that all the output values are 3 times as large. Now a vertical asymptote can't be 3 times as large because it's already going up to infinity and down to infinity. So the VAs don't change values. But the numbers, the range here, these can be 3 times larger. So like 3 times 1 is 3. 3 times 0 is still 0. 3 times negative 1 is negative 3. So there's a vertical stretch because of this 3. Now this 2 is actually making the function shorter. It's a horizontal compression. It means it's going twice as fast because it's always like inversely proportional. So let me write down the formula. So the formula for the period for cotangent, since it's a shorter function, it's pi over b. So they're saying b in this case is a 2. So the period now is going to be pi over 2. So that's the width of the graph. One cycle is pi over 2, where usually the width would be pi. So it's half the width. It's a horizontal compression. It's squeezed horizontally. All right, now the increment is still the period over 4. So you're going to do pi over 2 divided by 4. Let me just write that out the long way because it's easier for people to get that. So right, I'm going to convert it to multiplication, so it's going to be pi over 8. So that means that the jumps between the steps are going to be pi over 8. And you don't need to do the start or stop for the cotangent. Since it starts at 0, we just have to make sure we stop at pi over 2, because that's the width of it. If you start at 0, you travel a width of pi over 2, you're going to end at pi over 2. Okay, so let's see here. So you're going to start at 0, then you're going to add pi over 8. Okay, then you're going to add pi over 8 again. So that becomes 2 pi over 8, which is pi over 4. Then you're going to add pi over 8 again, so that's 3 pi over 8. Then you're going to add pi over 8 again, which is 4 pi over 8, which is pi over 2. Okay, so if you start at 0 and you're with a pi over 2, you're going to end at pi over 2. And again, I didn't need to do the start or stop because on the cotangent function, because it starts at 0, there was no left-right shift on this. Left-right shift means that like in here it would be like plus pi over 4 or something. There'd be something x plus or minus something here. So let's move this over. Let's see here. We're going to graph this guy. All right, I'm just going to look at these numbers for a minute so I can scale it. The x's are really tiny, the y's are really large. Okay. All right, so pi over 8, pi over 4, 3 pi over 8, pi over 2. Okay, that's where our VAs are. The VA is here. And there's another one here. Okay, and this guy is, so this is 3 over 8, that's less than a half. 3 over 4, that's a, alright, so 1's a little bigger than that. Okay, so alright, so at pi over 8 we were at 3, and pi over 4 we're at 0, and then we're at negative 3, negative 3. Okay. This guy's just really stretched. This guy's just really stretched out. Okay. Yep, this guy's just like super stretched out. It's compressed horizontally and stretched vertically. So it looks a little weird. I'm just going to draw 2 of these. Okay, so we're up here at 3, then we're at 0, and then we're down here at -3, and we're all stretched here. Alright, so this is your y equals to 3 cotangent of 2x. Okay, gang. I hope that helped. So using the table method to draw the graph, and then once I got one core example of the graph, I could then just repeat and repeat and repeat and repeat. Okay, catch you again in another video. Hope this homework question helped. This was number 27 on 4.6. Okay, bye.